Our next speaker is Mayank Agarwal, who's going to tell us about massive studies of moral cognition. He's from Princeton.
All right, thank you all so much. My name is Mayank Agarwal. I'm a PhD student here, and this is joint work with Josh Peterson and Tom Griffiths. So one of the most kind of recent high-profile big data experiments is this moral machine experiment. This was published in Nature close to the end of last year, and it comprised of roughly 40 million moral decisions by individuals in over kind of 200 countries. And then they published this whole data set online, and this provided us kind of like a really interesting opportunity to see, what can actually a big data study inform us that, smaller scale studies can't. And for those of you that don't know what the moral machine experiment is, it's based off the Trolley Car Problem. In the Trolley Car Problem, an individual must decide whether to, not do anything and let a train, kill 5 railway workers, or they could pull a lever and it will go on a sidetrack and kill 1 person. And so the moral machine researchers kind of did a similar scenario, but dealing with autonomous cars. And they had kind of 2 different types of paradigms. I'm going to be focusing on one in which there's an empty autonomous car headed towards 2 sets of pedestrians, one on the left side, one on the right side. So here you have an empty autonomous car headed towards a girl, an old woman, and a dog that are illegally crossing, and then a stroller, a woman, and a dog that are legally crossing. And the question that the moral machine experimenters asked participants is, should the car stay or swerve in this scenario? And there's 20 different types of characters, as well as different crossing signal configurations, and the car can be on either side, which resulted in a really, really rich problem space. So there's 15 million, this is greater than 15 million of these decisions, and over like 3 million unique types of dilemmas. And we kind of just wanted to ask the basic question, okay, for any given configuration, what do people want to stay or swerve? And we wanted to see, what the best predictive model we can create is. So first, just from standard psychology, we just built these rational choice models. We're saying, there's going to be a value of the left side, there's going to be a value of the right side. That's kind of just a weighted combination of the features, and then you just apply kind of a softmax function over it to see, whether individuals prefer to stay the left side or the right side. And so we trained 3 models of this. So one is a utilitarian model. So there's 20 different kind of agents, and we just said, can we infer what the value of each agent is? So how valuable is a man, how valuable is a woman, et cetera, for all 20 agents. The second model was a deontological principle. So here, what's important is not really the utilities of the agents, but fundamental moral principles at play. So one moral principle that was at play here is that if you were illegally crossing, you were probably penalized. And second, if saving you required the car to swerve, that was also probably a penalty. And then lastly, we just constructed a hybrid model that was just a combination of all those features, because people exhibit both utilitarian and deontological tendencies. And so this is just like a logistic regression model with 22 variables. Because we just had a lot of data, we could just train like a black box neural network and just see, how well can it perform. So we just kind of gave it the inputs, which of the 20 characters were on the left, which of them were on the right, what the crossing signal is, where the car was. And we just wanted to see kind of how this could perform in comparison to the rational choice model. And so here I have some initial metrics. So I have the AIC, the AUC, and the accuracy. We can just look at the middle one, the AUC. So what we see is, so the green is the hybrid model. It does pretty well, but as kind of Tom was pointing out yesterday, a lot of these choice models, a lot of these psychological models have a relatively flat line when you plot them over different data set sizes. Oh yeah, sorry, the x-axis is data set sizes, so we constructed subsets of the data of corresponding sizes and see how well the models could perform there. And interestingly, what we saw with the neural network is that it performed worse than the logistic regression model at a small data set sizes, but once it got enough data on the order of 100,000 decisions, it started to outperform the hybrid choice model. And kind of what this told us is that there's the neural network almost serves as an upper bound of the amount of explainable variance in the data set. So the fact that the red line is higher than the green line, that means that the hybrid model, the green model, there's something missing from it, right? There's something that the neural network is predicting correctly that the hybrid model is not predicting correctly. And we could just look at this graph and say, the neural network is a better bound model of human moral cognition. But I think many of us as psychologists want kind of interpretable and explainable models, and that neural network is really not interpretable. So, ideally, we would be able to construct a logistic regression model, some variant of that hybrid model that is just as good as the neural network. And so basically how do we do this? There's a pretty kind of systematic way of doing this. And this is really just the application of the scientific method to kind of data analysis. So, the scientific method is just this like iterative procedure between kind of theory and experiment. You make some observations, you build a hypothesis, you create an experiment to test the hypothesis, then you see where it went wrong, and then you kind of iterate upon it and kind of apply to data analysis, which is, you build a model, you train it, you fit it to your data set, you see kind of where it goes wrong, and then you maybe try to incorporate some new features or something along those lines. And what's really kind of important in this procedure is this method of residual analysis. So you fit a model to the data, and then you see what were the biggest errors that it made. And then, hopefully you can see from the biggest errors that it made, there's some new features that you can incorporate and try to, predict those correctly the next time. And so we did that with the moral machine data set. And so here, what I've showed you is, what I'm showing you is the largest errors between the data and our hybrid regression model. And so what's really interesting kind of is this top one. And so here, a car is headed towards a man, a woman, a girl, and a male executive. And on the other side is a dog and 3 cats. And apparently 99.4% of the participants said to kill the people. And the choice model only predicted 11%. Hopefully we can all, as indicative by Il's laughter, there's something weird going on here. There's something wrong. Intuitively, this seems like noise. But it's unclear if we can be sure about that. But what I want to suggest today is that there is a method that we can say that, this is probably some noise in the data set. And so because we just trained a neural network on it, we also have the neural network's prediction. And we see that the neural network predicted only 16% of participants kind of would kill those people on the left. And if we really, if we compare choice models to the neural network, it seems like both of those, that choice model is actually predicting it correctly. And so we can think that the neural network is, trying to smooth out the data. There's going to be some noise in the data, and then what the neural network is trying to do is try to smooth it out. And so it would be a lot kind of less sensitive to the noise than the data. And we believe that the neural network's prediction here is actually more correct than the data, because so we look at all kind of the similar dilemmas to that. There's around 40 to 50, and in all those examples, it's 10 to 25% of people predicted to kill kind of the size of a human. So it really seems like the neural network is kind of predicting it correctly. There was just kind of a lot of noise in the data set. And similarly, if we see here, the car is headed towards an illegally crossing old woman and pregnant woman. And on the other side, there's a dog and a cat. So the data said 5% of people chose to kill the humans, where the neural network said 25%. And so the choice model got it wrong in both scenarios, but whether the correct answer is 5% or whether the correct answer is 25% will influence how important kind of this residual is, how much does the choice model err in this. And again, we think that the neural network is actually a more reliable estimate of this, and we looked at all kind of similar dilemmas. There's around 20 of them, and in all of those dilemmas, the actual rate was between kind of 15 to 35%. And so it does seem like that 50% kind of was an outlier. And this kind of suggests kind of a new way, a slightly different way of kind of analyzing these residuals, and we're going to call this scientific regret minimization. And the idea here is that once kind of the data set gets large enough, a machine learning model such as a neural network can actually approximate the true function better than the data. And it'll actually just, smooth out the examples. And as a result, if it's a better approximation of the true function than the data is, we should use the residuals compared to the neural network than to the data. As we saw, the top residuals, with respect to the data, often reflect noise, whereas to the neural network, we think that they don't. And so kind of we apply this methodology, and so now here, so the big idea is we want to critique with respect to the model, not the data. And kind of the intuition behind this is you only want to penalize for mispredicting examples that are predictable, right? Because if I mispredict something, but the neural network predicts it right, that's telling me that there's something in those inputs that the neural network was able to, figure out and predict the output correctly. But if no model can really predict the output from those inputs, that suggests that, there might be noise in the data. And so as a result, we looked at the top residuals with respect to the neural network, and we can actually see that the neural network and the data match pretty well here. And kind of here, what we saw was immediately obvious. So we had an empty car headed towards an illegally crossing human, and on the other side were illegally crossing animals. In all these cases, the data in the neural network kind of predicted people to, swerve and kind of kill the animals. But the choice model, our kind of hybrid logistic regression model, predicted the opposite. It actually said people should go, the car should go straight and kill the people. So clearly, kind of this is wrong. But thankfully, because this choice model is only like 22 parameters, so it's kind of a logistic regression model, we can kind of look into the parameters and the weights and see why is it mispredicting. And we were able to say that, so take the top example. We could see that, the man had a much higher utility than the cat, but there was a big penalty for illegally crossing, and there's a big penalty for swerving, and kind of the model inferred that those two penalties are greater than the penalties, than the utility difference between a man and a cat. But again, as the data of the neural network demonstrated, this is clearly not the case. People are not, choosing to go forward and kill the human. And what's really clear is that this is a humans versus animals dilemma. And in these types of dilemmas, humans should be preferentially saved, even if they're kind of illegally crossing or if they're in the way of the car. And so what we did is we flagged all dilemmas of these types that just had humans on one side and animals on the other, and we actually added that as an additional predictor of our logistic regression model. So if just one side was humans and the other side was animals, this would just get kind of a binary indicator that, hey, this is the humans versus animals problem, let's give a boost to humans. And in fact, there's 6 of these manipulations that the neural machine researchers explicitly did. So there's humans versus animals, there's old versus young, male versus female, high status versus low status, more versus less, and fat versus fit. And so we kind of incorporated these 6 features about, what the people on the left versus the people on the right, and we kind of incorporated them back into our logistic regression model. And so here, the pink dotted line is kind of the regression model with just those 6 more features. And we see that we recover almost 50% of the gap between the hybrid choice model and the neural network. So it really suggests that we're able to kind of close in on that gap. This is adding a lot of predictive power to our model. Furthermore, just as a test, we put those features back into the neural network. And what we found was that the neural network with those 6 new features did better than the neural network without those 6 features at the small data set sizes. But once the data set got large enough, those 2 networks are virtually indistinguishable. And kind of this suggests that, once there was enough data, the neural network was able to construct those features on its own. And so, this is an iterative procedure, and we kind of kept on doing it again. And so now here's the second iteration. So on the left is the top residuals with respect to the data. Here you can see actually the neural network and the data are very opposite. And in fact, the neural network and the choice model almost always correspond. But the traditional analysis of saying where does it err on the data would have said that these were problems for kind of the psychological choice model. But the fact is that because it's performing really similarly to the neural network, we can say that the data was probably noisy in this case. And so instead, we kind of focused on the right, which was the top differences between the neural network and the choice model. And we just kept on doing this again and again and again. And I just have plotted kind of the different iterations of the model. And so we kind of essentially found some new axes of differences, as well as some interesting interactions between those axes, the crossing signal, and the side of the car. And we were able to get kind of a logistic regression model that has very similar metrics to the neural network. But in virtue of being a logistic regression model, we could interpret all of the features and know kind of what their specific weights are. And so this way, we have a model now that jointly maximizes both explanatory and predictive power. So scientific regret minimization is a form of exploratory data analysis, and that's really just one half of the scientific method, right? That's just figuring out the best model that fits best to the data. But the other side of this is that we have these hypotheses, we have these predictions of what's going to happen. We need to create experiments that can isolate these variables and test the predictions of these models. And so we wanted to confirm kind of some of the interesting stuff that we saw via some pre-registered experiments. And basically, throughout by going through this procedure, by seeing where our model was was having errors on the data, we were able to find some new and interesting empirical phenomena. And if you and we're gonna talk about three today: the dehumanization of criminals, the age of responsibility, and asymmetric notions of responsibility. And so I should point out, this data set that we're working on had 3 million unique types of dilemmas, right? So if you were to go just very naively into it and just find something interesting, it would be very difficult to do so. It's not really clear how you would do it. And so what I want to propose to you today is that this method, scientific regret minimization, is a way that we can systematically identify kind of interesting empirical phenomena. So the first one that I want to talk about is called the dehumanization of criminals. So I talked before that we were messing up when there was a kind of humans versus animals, and that we had to create a feature that flagged that to give a boost to humans. And so this kind of improved our model a lot, as you saw. But we then started to err on a subclass of dilemmas, specifically when there was criminals versus animals. And it seems like the model started to predict that people would actually save criminals more than people actually were. So it seems like the humans versus animals boost that was really useful was actually not being applied to criminals. And so we actually had to remove that feature from the model when it was just a criminals versus animals, kind of removing the human feature from criminals. That's kind of dehumanizing it in the eyes of our model. And so then we kind of ran some pre-registered experiments on what is the probability of saving the criminal when it's against a dog versus homeless person versus dog, old man versus dog, man versus dog, over all three crossing signal conditions and both sides of the car. And in every scenario, we see that people significantly save criminals at a lower rate just when the other side is a dog compared to other human parameters. Awesome. So the second one I want to talk about is kind of age of responsibility, and this is kind of a subtle effect. So I want you to consider this dilemma where you have an old woman versus a girl, and you're trying to figure out who to save. And now consider the second dilemma when you have an old woman and a woman versus a girl and a woman. And so now most kind of rational choice models are based on a linear utility function. And so they would suggest that actually these two dilemmas are equivalent, like the women cancel out kind of in the second, right? The woman on the left cancels out the woman on the right. And so the question for us is that, do people actually treat this dilemma similarly? And so what I'm going to do is I'm going to separate these out into different crossing signal conditions. So on the left side, the side of the girl is crossing legally. In the middle, there's no crossing signal, and on the right, the girl is crossing illegally. And what we find is that in the left two cases, people treat those scenarios the same. So whether it's a girl and a woman, the probability of saving them is similar, but it's different when the side of the girl is illegally crossing. Here, the girl is saved at a higher rate when she's by herself, when she's illegally crossing, than when she's with an adult and they're illegally crossing. And so then we kind of conducted a pre-registered experiment about this, and this was kind of a little noisy, but basically, and that top right was essentially what we were going for. You have these null effects at the no crossing signal and the legal crossing signal, but when the girl is crossing illegally, there's going to be a significant difference between the two types. And we did it both for male and female as well as for kind of both sides of the car. Awesome. So the last one I'm going to talk about is called asymmetric notions of responsibility. This was definitely kind of like a surprise for us. It was interesting to find this out. This seems to generalize to kind of all cases when there's just like a higher valued individual versus a lower valued individual. But we kind of found it first in the male-female dilemmas as well as the fat versus fit dilemma. So I want you to consider the case when there's a car headed towards a woman, and then on the other side is a man. And more specifically, let's again go through all of crossing signal conditions. And so the probabilities are, this will be, what is the probability that the, either woman is killed or man is saved? Those are equivalent. So when the man is crossing illegally, the probability of saving him is around 22%. When he's crossing legally, it's around 76%. And now the interesting question is, what happens when there's no crossing signal? And what we find is it's 49.7%, which is roughly like, right in the middle of 22.5% and 76.3%. So it seems like, when the car is headed towards a woman, to treat her, 50% as if she's crossing illegally, 50% as if she's crossing legally. Now, the interesting part is what happens when we switch the side of the car. So now the car is headed towards the man, and you have to decide whether to kind of swerve and kill the woman. So again, now when the man is crossing illegally, there's an 11% chance of saving him. When he's crossing legally, there's a 67% chance of saving him. And the question I'm going to propose to you is, what is the probability of saving him when there's no crossing signal? So hopefully, with the way that I set it up, you're going to guess, the mean. So it'll be around like 39%. The actual answer was like 19.8%. So it's dramatically different than what you would expect, kind of suggesting that, in this ambiguous case, the lower valued individual is kind of presumed to be, crossing illegally as opposed to legally, whereas when the car is headed towards a high valued individual, it's kind of 50-50 split. So then we did kind of a replication of this. So we did man versus woman, old man versus old woman, large man versus male athlete, and a large woman versus female athlete. And we were expecting kind of null effects between kind of the middle green dot and the dotted line, and then significant effects between the middle purple dot and the dotted line. Great. So just kind of some takeaways, critiquing with respect to the data and really large data sets, especially the noise, you just have so many types of dilemmas, just bound to be noise, and those are going to kind of propagate up to the top when you're looking at kind of the top errors. But the power of the machine learning model is that it can smooth the residuals. So, and because it provides kind of a better approximation of the true function as opposed to the data, once the data set's large enough, we should actually use this to, guide residual analysis. And this procedure, hopefully, I've demonstrated helps, build a better model and identify some interesting phenomena. And just kind of like as a last note, I want to put up this picture. Most of you are probably familiar with the hexagon. Kind of what really drew me to cognitive science is that it was the intersection of all of these disciplines that I was really interested in. And the more time I spend doing research in this field, I realized that it's not as integrated as we would often like it to be. Oftentimes, research proceeds independently in these different fields. And I think there's many reasons for this. I think one reason is that each field kind of has different values. So, for example, psychology really cares about interpretability and the explanatory power of its models, where say, machine learning researchers really just care about predictive power and benchmarks on data sets. And I really think that, in order to build kind of an integrated cognitive science, we're going to have to kind of integrate these values across these fields. And so, I think, with big data, we can start to integrate, psychology and computer science, and build models that are both really have a lot of explanatory power and are interpretable, but also predict really well when it comes to large data sets. With that, I just want to thank my co-authors, one of my advisors, Tom Griffiths, second author, Josh Peterson, as well as funding resources, and just thank the audience. Thank you so much for listening.
This regret minimization idea is really cool. I wanted to I wondered if you thought very much. So maybe you have some simulations that can show me that that it would be reasonable to expect noisy responses, but I was actually a bit surprised from what I'm used to with these kind of data sets. And I was wondering, to the extent that you feel like you could find or have thought about, let's call it adversarial responding, which is a phenomenon. The one that comes to mind is there's this famous XKCD blog post which they analyzed a large color naming data set. And they found, and one of the things they were interested in was gender differences, and they did find that generally people gave, regardless of gender, the modal response for a particular color was the same, but you could analyze what was the most male response or the most female response, right? And for female, here were the most female words: dusty teal, blush pink, dusty lavender, butter yellow, dusky rose. Here were the most male: penis, gray, WTF, dunno, and beige.
Yeah, no, that's interesting. One thing that so for our models, the only kind of input variables.
Completely that I believe beige misspelled.
You're justifying hitting the man instead of.
True. Yeah, so the inputs to our model was really just the description of kind of the features and paradigms. And so I think, one potential way to extend this would be to add more input variables corresponding to, what the genders of the participants are, what the countries they're from, and stuff like that, and see just add additional information.
I guess I was thinking more broadly, is there a way, find a way of detecting maybe items in which you might get sort of adversarial responding? So I actually interpreted the laughter about people avoiding the humans, the animals to hit the humans differently, which is also like the 13-year-old boy in me thinks that is exactly the right response to give there. Yeah. And so anyway.
Yeah, well, that is interesting. I guess the problem would be then all the other humans versus animals dilemmas where people were wanted to save the human. So if just that dilemma for some reason had 600 trolls as opposed to none of the other dilemmas did, we don't know. But yeah.
Can I ask how many times did a typical participant actually evaluate a given situation?
So in the moral machine, they did 13 decisions, and so 6 or 7 were when there's an empty car headed towards 2 sets of pedestrians. There's another paradigm which I didn't discuss when there's people in the car and then there's just 1 set of pedestrians. But they made 13 choices.
And do you see any change over time?
We didn't actually do that, so that would be an interesting.
You can imagine that's where some of the noise comes in.
Yeah.
Right.
For sure. Yeah. So we when we were doing our replications, we had to be pretty sensitive to the amount of kind of dilemmas people had seen kind of before and stuff like that.
Right. And then you could also imagine that I could imagine if I'm confronted with this dilemma, the first one is just going to be terrifying.
Right.
And then you get used to killing people.
Right. Yeah.
So that would be really interesting.
Yeah. No, for sure. Yeah.
My questions are about the models, actually.
Okay.
I was extremely surprised that the choice models were doing so poorly. I was thinking it was really, at some point it was really bad, like one of the tables that you were showing me. And also, did you try the neural network model on data from experiments that were not collected in this? Because there's a lot of trolley experiments involved. I wonder whether there's something about this particular way of portraying that, generates a different kind of reaction. But your neural network should equally well perform, the one that was the best performing, on data from, I don't know, Josh's lab at Harvard or other people who are, who have done experiments on this, right? It was a little confusing for me whether there was something about this data set that was so weird. And also I was wondering how the mixed models could do so poorly. In one of your tables, it was constantly preferring animals. There was a table at some point in one of the iterations.
Oh, right. So this
This one, yeah.
Yeah.
It kills humans always.
Right. So this is because there was because in general there's just a really big penalty for swerving and a really big penalty for illegally crossing. And then that just outweighed kind of the utility of the difference, right? But this choice model didn't know that it's just pitting humans versus animals. Like that's actually a pretty complex interaction that it just like didn't have that feature.
And that penalty from the utilitarian or from the ontological?
Both combined. So there's this hybrid model, which is all.
So that's the thing. Like, I can't imagine any philosophical argument in which killing a human and swerving to the left would be equally penalized. That's why I'm confused about how the parameters of that model were set. But that's I guess, the initial parameters of that model. I'm confused.
So there's no, you'd be surprised, right, for the philosophical argument when like of killing the humans when there's animals on the other side, right? But this choice model wasn't able to really say that, okay, there's only humans on the left, only humans on the right. But if it knew that that was the relevant kind of axis of difference, which is the feature that we incorporated, then it started predicting it correctly.
Let's get one more question and then.
A question about interpretability. I really like this idea of using the ML model as sort of the gold standard and pushing your interpretable models to add more and more complicated features. I guess the question is, how far do you take that, right? I mean, this is a pretty simple scenario by the standards of like all the things
right.
that are trying to explain in the world. And already you ended up with like a lot of interaction effects and sort of fairly features. So already at this point, your interpretable model is not really that interpretable. So you can imagine as you have to keep adding more and more and more of these kind of handcrafted features for, to get smaller and smaller amounts of, experience. How do you think about like when to stop and admit that the system is not really that interpretable?
Yeah, I think, one thing that we've been talking about is what exactly is there really an objective definition of interpretability? And it seems like at least we couldn't really come upon one, and so, we just got that, logistic regression model where we knew what every single feature was like a good heuristic. Yeah, I agree. So, I mean, I think we will kind of start to realize this as we start to kind of analyze the data, that there's going to be some interesting but like systematic kind of variation. But we're going to have to kind of account for those, and those might be kind of really weird, obscure features. But if that's a feature that is representative of human moral judgment in this case, then we should kind of incorporate this into our model.
Thanks, Mayank. One of our goals with this workshop is to increase the density of the social network of people who care about these sorts of issues of scaling up cognitive science. We're about to take a coffee break until 11 o'clock, and I encourage you all to, during this break, introduce yourself to one new person, because adding new connections is a good way to make the network denser. See you at 11.
No, yeah, so I think what you saw on the data, like people simply the dark, 70% of those are close to 700. So we only looked at
Well, what I'm interested in.
yeah, but it's just the interesting question. I guess the interesting question is there's a lot of those that want to there's only that one, right? So yeah, if we saw like the balance and
Hi, can you hear me?
right, yeah.
Originally,
Hi, can you hear me?
Yeah, I think one thing we were interested in now we have this fun, I think.
Let's check.
They're the exact same. I felt like we were, it wasn't the exact same paradigm, but they were just
well, but it's the same, issue, they're all, and I asked them, said, well, what would you do if you had then you know that, right?
Yeah, I agree. Yeah, so we tried to kind of
But it's not easy to say, okay, we can get you.
Like the girls who believe that don't like
that's the problem, right?
Like children have special status, they're not as liable for crime as say but I agree like replicating is completely different paradigm like not on this part. Then you can show I agree. Exactly. So we hope just like these effects that we found, kind of interest people in say what
Hey, everybody. Are you able to see my presentation?
Try that one more time.
Can you see my presentation in full presenter view?
No, you'll need to flip it to, if you look at the screen sharing option on the actual GoToMeeting panel, underneath, yep, there we go. Now we see it. Yep, and we'll move forward. All right.
Okay, perfect. And can you see my face as well?
Yeah. There's like one of the real.
Yep, we can see both.
Okay, so I'll mute and then I will come back in 10 minutes.
Okay.
Great.
That's what I was thinking trying to like, it won't be the best. I'm just hoping it doesn't cause a feedback loop, which it shouldn't because it's not on the same system, but you never know. Now, when he is done with his presentation, you'll need to turn back down back down to as low as it'll go. That way, anyone else that logs in, you guys won't hear. Okay. Do you want to try and get on the GoToMeeting in another room and just talk into it so I can hear what it sounds like? Since he left the space?
Yeah. We can do that, or we can just, he can try starting it, and then if it works.
Well, I want to make sure there's no feedback loop.
Yeah.
Because if there's a feedback loop, that's going to hurt your ears.
Yeah.
So can we please have someone do that?
Yeah. Yeah. Okay. Which room should we go in?
Well, I need to be here to hear it.
Yeah. Which room should I go in?
You can even be out in the hallway.
Okay.
It's just not in.
Oh, like, okay. So it's not another GoToMeeting setup.
Yeah. I just need you to talk into the GoToMeeting.
Okay, can you hear me?
Yeah. Yeah. Do it. I did it because like I get me back. Yeah. And if I were to leave it any later. Yeah. No, I use the max out one.
According to this.
Well, I was gonna probably leave it there, and then I see where I'm going to go.
Yeah, I was on.
I was probably either gonna eat here if I did, or just walk back, grab my stuff.
So again, I think it's better with that. Yeah.
That's what I was worried about.
Yeah, I think
Yeah, it's gonna be all we got.
Lunch ends at 1:30, and then we're in Florida until 3. Like training 3:18.
I'm glad we checked because that could have hurt.
yeah.
But that I don't know what.
Time to like navigating, because it is a big deal.
Yeah. Same. So I was thinking of like staying for lunch and then leaving like 1:30 to take an actual break. And I'm there kind of early. I don't know.
I've noticed that I've used it list, right? Or not list, maybe the people here are like meaner. Every single person that I've had, I know what they call it,
Yeah.
and like living rooms, I use it to talk to people.
Really?
Yeah. And then this guy, he was 20 minutes to come get me.
That happened to me. Where's your
Down one, it's like 10 minutes like towards the direction of the train station.
Okay.
And so their algorithm seems like gives them a new run before they finish the curve.
Yeah. That's what I know.
So he's like literally, and it's like, oh, the estimate is like a 30, 44. Here's I will get here.
And you can't cancel because then you get charged money. Yeah. Yep. Yeah, that happened to me today too. But no, I mean, if you change your train, what time would you be leaving theoretically Wednesday? Lunch ends at 1:30.
Also, I mean, I prefer not to be like putting it close to the time of the train. If the train comes early, they'll wait until the time of the train. But at the same time, I want to make sure that I get. Oh, with fine. I don't know if I just real after this, right? Like on the way here, it just hadn't hit me yet.
Yeah.
I mean, I suspect that a lot of people get off from here.
Agreed. Well, I mean, if we're gonna be on the same train, might as well sync up our travel plan.
Yeah, I'm gonna actually bust up my computer and hit into the phone.
Yeah.
And then see about changing the trains that maybe I get from a little earlier. I don't think a lot of people think there's somebody else they were leaving earlier.
Yeah, it's always a challenge. I mean, that's like with the MBR2 meeting, we've designed it to end at noon, so people have the ability to like leave.
Yeah, Adam's meetings usually
whatever the last day is, yeah, just to be more accommodating to travel. Yeah, I think in that case I'll probably listen to Grant, say hi if I haven't gotten to here. I don't know. Okay. Good. Yeah, I want to meet him. I talked to him a bunch. Also, no. Yeah, I joined. So when Brandon left, I joined April, May. And the PI meeting was online.
Yeah.
And so.
I was talking to him, trying to figure out like when he would be done collecting their data, figure out when the enabler will start with the data, figure out when the next PI instantaneously will be.
Yeah.
I think the computer was maybe February.
Yeah, it sounds like they've run into a few more snags because like the Mayank prediction market team, they are just waiting. You know, but it actually is kind of fortuitous for us because the prediction market team, they've revamped and made better their predictions in the market. So much so that they have to go back to Royal Society Open Science, like, hey, we changed stage one. They actually were doing a register report format for this. They got approved, but now they just need to update it. It's not a lot of changes, but it's going to take time with the journal. So that kind of works out. But yeah, I saw like the last thing I've seen on the Gallup and at least on the OSS side of things. Halloween. They uploaded some pilot data for the Polygraph World Halloween. So hopefully.
Thank you for the privacy calls with
yeah.
As well. I was interested in casting to thank you guys.
No, I'm gonna.
They just talking about delay the picture. One of the delays with the Zoom conversation basically not able to do it.
No.
Because like there's like latency issue.
Yeah.
And when they hit like a certain amount of time, so they've been doing like mostly matters and asking if they could do it doesn't have to like do it in US. It doesn't matter as long as US position. for that. That's something that they've actually exploring. And then, you know, with choice, they have to do multiplayer games. Because it's going to find it seamless, you know, miserable.
Really?
Yeah, because, you know, these people are all people who should be good. So when they log on, they don't index the
Yeah, I guess, yeah, there's nothing to keep them there. If they log in and they happen to be able to go, and they're like, because I guess, yeah, that makes sense, because their goal is to get in to play this game. If they get in to then wait to play the game, it doesn't make sense. That's tough.
Yeah.
So what are they going to do?
I don't know, so
Yeah, make an interactive waiting room so people enjoy the time they wait?
Sure, because this would be the time that we would have been having a phone call. I'm here. Adam, one of the players. I think no one's going to do that.
Yeah, fair.
It doesn't have to be, yeah, it doesn't have to be based on the report that we should see. You know, if I ask Grant to have a phone call, maybe you should dial in. Are you going to be back? Are you going to be working on Thursday?
Like 2 days from now?
Yeah. Okay. Maybe I'll ask Grant to forward you the information from the publisher. Let that sort of plug in as a monthly phone call.
Okay.
And then Adam will be doing it.
Okay. Yeah, I saw we had a check-in with the minor calls tomorrow, but we will be in this room during that scheduled call.
Yeah.
So I went ahead and distributed that.
And we mostly go to the
Well, they're trying to get a hold of Adam. It's the name of the game for them.
Yeah. And Adam is aware of it, but he doesn't really have last name is Howard.
Yeah. Yeah.
I haven't seen Adam actually. He's gone all last week.
Yeah.
The last week we just last. He was in Australia.
During all the heat and fire.
Probably. And then I'm here this week.
Yeah.
And if I was getting this, I wouldn't think that we could get it.
Busy. Especially, it's crazy to think that it's this busy this close to like in the middle of the holiday season. I didn't expect you guys to be go, like up into Christmas Eve.
It is pretty go because we get like a little bit of you know, with the move to school, you're starting to go in the morning. September is a little bit quieter. Because what about September stuff starts getting out there?
Yeah.
But in the fiscal year, it's really busy, almost a little bit quiet. And then once October goes, and they know how it is coming, it's kind of like this message that has to be for Thanksgiving and be Thanksgiving. And then it's like, and in January it's like, well, but then it's like November, December is just
Great. I didn't expect that. Huh. Yeah, that is weird.
you always expect it to be quiet because they know they're going to be on for like
Yeah. Well, hopefully, I mean, and hopefully you get to see Adam on Thursday. Yeah, that's what I remember too. He was tall. When I met him, he was tall and sick. So it's for text, and he had like a cold and flu or something. Oh no. What's happening? What is happening to this guy?
pretty bad.
He's a pretty healthy individual, usually, like I thought.
Well, he has like this mouth breathing.
I guess, yeah, that's the harbinger of disease.
Yeah.
Take care.
Work or
I have no
see if
yeah.
otherwise I could just switch to my laptop.
We had an infant face disease fire happening in the Western United States. Everyone's children, all their children go to daycare, and all the daycare is disease. They bring it home, and all the parents get sick. So our office is like very, very
Good. We're good. Thank you.
Because all the parents are just sick, and their kids are super sick.
I remember the first year that my friend put in daycare. The entire winter, she was sick the entire
Yep.
Kid is sick and she's sick. And the kid is sick and she's sick. And it's just like,
Yep. It's a good thing, but it sucks going through it because you're hoping to build the immune system, but then you have to bear the consequences.
yeah, there's only so many hours of work that you can pick up.
Yeah.
Pick up in the middle of the day to go pick up the chicken shop. If your kid is somewhere else, well, it isn't a kid, they can get to Ohio. And they go pick up their shit, but then you're sick, you don't know what it is. And then when it's everybody else, oh, the kid's sick again, I gotta pick up the kid again. And then when you're like the cycle every other week at a minimum just to get to help the kid. And the in between weeks from that, then you're
Yeah, that was. I don't know if I got my parents sick 'cause I don't remember. I just remember my experience. But I remember as a kid, I was strep throat and ear infections like from November 1 to February 28, 27, whichever.
to get the little food.
No, I was like this close to having to have that happen because it happened like clockwork and it stopped happening. And then I was like 8 and it stopped happening. But it was bad.
I don't think I was like called that. But when I was sick,
I haven't been sick in a while. It's rough, but
like I try really hard not to get a cold because when I do get a cold, it's pretty bad and it always involves in bronchitis.
pile on, yeah.
And then I end up having to use like an inhaler for a month afterwards because when I get like things, I don't even know if you get like a good out of it. Every time I get sick, I get a cough. Because it's bronchitis.
That turns into a cute pet.
And then I have asthma for like a month. And I have to use like those little inhalers and
Yeah.
little steroids like it's miserable.
Yeah, when you get sick, you go all in.
Yeah. About once every 3 years is when I get really sick.
When's the last time? Are you due?
I'm overdue.
Uh-oh. Well.
That's why I'm like, what?
Yeah, Adam. Talk to me.
He gave me like the, well, you're getting feeling like, no, I don't have time.
You have anything else?
I'm taking like a class like every semester.
Oh, nice.
Into the final exam is due on Friday.
What was the class?
Patient data accuracy. I was really excited about it, but then it was not a very good thing. Because most people spent
Through what institution? Georgetown. Huh. I was expecting something around your area.
This way I get to just, watch the videos at home.
Yeah.
The whole online thing is weird. And it's like all the other online things I've done have literally been, videotaping through you want to see. So this is like separately recorded videos.
Well, hopefully it was at least somewhat helpful.
It was somewhat helpful. I did learn, but not from the class. It was more like, here are the topics that you need to know from homework. And I'm like, okay.
Yeah, I guess it's a direct Google intention.
Yeah,
But that class.
Like, here's your keywords, and then go and do your thing, and then answer the question. People like to answer, like, let me give you this equation with like none of the people defined, like it's very rapid fire, like what the terms are, like orally in the video, but also like there's no sense of structure to the lecture. So I'm like, they need to stumble with the key. It's not just a new bullet. Like, I'm so confused. Like, are we in the same topic?
Yeah, that sounds very chaotic.
Yeah, whereas like whenever I do any of my homework, all of my notes, I just automatically put like outline format. I mean, that's how I keep my notes. I think very much an outline.
Me too.
Yep. And it's threw me off very much. Not place where this information fits into the topic. Yeah.
That's not a good sign if you're the lecturer if you cannot place the content within the umbrella where it lines up. That's right.
And then it's the thing with like restarted for a lot of sentences, which for normal speaking is okay, but when you're giving dense information and you restart the sentences,
Just bloating the listening time.
yeah, and it's very confusing. You'll start the sentence saying like going in this direction, and then sort of restarting it and going in this direction. It's not changing it, but I'm like, are we still going in this direction or are we going in this direction?
Can you edit that out too? Can't you make edits if you're going to restart?
And then there's like transcription doesn't understand shit that either.
Oh.
They'll be like, square brackets inaudible, and I'm like,
Is this the first year it's been offered like that? I feel like you would go in and clean it up after over
this
time.
is the first year that teachers get money. I don't think they're a little weird about recording.
Yeah.
And I think
That's fair. I feel that way.
it would throw me off too. But at the same time, my job is not like that.
Good point. That is a good point. Yeah, well, at least it's over. I mean, at least you got something out of it. Finished.
Yeah.
You know you're going to take some spring?
I was going to take simulation class. I'm actually trying to decide whether, I guess I should email the organizers, like, see what I should do, see if I can get such a professor for the course. Because I'm going to get surgery in the middle of the semester.
Yeah.
It's fine, but the recovery time for this degree here, it would be like a week, or, basically right after class.
Yeah.
Yeah.
What exactly is being done?
So,
Yeah.
They think about that.
Yeah.
Shockingly, like, but it's coordinating there.
Like if I use my finger.
Really?
Yeah.
It's mechanically.
Open your fingers.
I can't pull it. No, this starts to come up.
Yeah, my left.
Pretty much.
Like, yeah, you put the distance on there. I can't do it. It's when I have problems that apply. Oh. That. Right. Yeah, that would end up right in this area.
Yes. Oh, Mike? Hi. We're not starting quite yet. I just wanted to say hi. This is I don't know if you can't see. I guess this is Jordan Suchow. I'm going to introduce you in just a few minutes. But we haven't started yet.
Well, let me know if you
You can also chat with him out here. It's hard to hear.
Great.
Although you do use